All right, welcome back. I hope you enjoyed taking the ideas we explored in that proof. I don't need to be wearing headphones anymore. And taking them and composing a proof in your own words. I think that's an important exercise to do. I hope you've done it. Maybe I'll point out one thing. In what I recorded, I kind of stopped right here. It's kind of important that epsilon over 2 plus epsilon over 2 is equal to epsilon. That's kind of a crux of the matter, so that's on me. But let's do what, kind of the whole point of this pair is, let's do something that's more difficult. That's kind of what the point of these videos is going to be. Things that happen in class that are harder to follow, because we're going to do some difficult things, will be put in these videos. And some of them I'll not do in class and then do them in these videos. And that's, I don't know, I'm figuring this out as I go. Anyway, stay on topic. We are going to prove the exact same result as before, but with multiplication. Let A and B be numbers, let A sub n and B sub n be sequences. I suppose I don't need to assume they're convergent right here, because in the next line I'm assuming that A sub n converges to A and B sub n converges to B. Then the conclusion is A sub n times B sub n converges to A times B. So first, let's try to compose an incorrect proof. Well, so this is going to be an incorrect and fairly informal. You should start with some declarations. We'll just try to get ideas. Since A sub n converges to A and B sub n converges to B, we can arrange that A sub n minus A is as small as we want, and B sub n minus B is as small as we want. Well, exactly like before, we want to get A sub n times B sub n minus A times B to be small. And I'll do a really common trick. I'll find like something that has to do with both of these terms, and I'll subtract it and add it from this expression. That won't change anything. That's a really common analysis trick. Let's see what happens when you do. So this becomes A sub n times B sub n minus A times B sub n plus A times B sub n minus A times B. And what's the point of doing that? The point of doing that is I want to use the triangle inequality eventually. I can only use the triangle inequality once I get down to things that I'm convinced are small. I mean, you can use it before that, but you won't get a good result. So let's try to analyze both of these, and at least informally try to convince ourselves that each of these things is small. I think I have enough space to keep on going. That is equal to, both of these have a B sub n. A sub n minus A times B sub n plus A times B sub n minus B. Aha, so here's the point. Look at this bit. We assume that this bit is as small as we want. We can put any small number there once we use the triangle inequality. We can put any small number here using the triangle inequality. That B sub n, well, it's like close to B, so it's not gigantic. That A is, well, a constant, so it's obviously just as big as that constant is. So we'll wind up with some things that aren't gigantic times some things that are small. That should wind up being small. That should be encouraging that this proof should walk out. But let's just continue writing it. Again, as a reminder, this is going to be a false proof regardless. See if you can spot when something false happens. So let's use the triangle inequality. That's less than or equal to, and also distribute some absolute value bearers, right? The overall multiplication, absolute value behaves nicely under multiplication. A sub n minus A times absolute B sub n plus absolute A times absolute B sub n minus B. But hey, check it out. We assumed this was as small as we want. We assumed that was as small as we wanted. Let's make those as small as we wanted the same. I see now absolute value of B sub n plus absolute value of A times whatever we put in that blank. So now you look at this and you say, well, if this were an epsilon, I'd be happy. What could I put in that blank to make this thing be an epsilon? Well, let's put, and maybe for color coordination reasons, Cool. So that means that, what do I want in these blanks? Epsilon divided by absolute value of b sub n plus absolute value of a. In this blank, I want epsilon divided by absolute value of b sub n plus absolute value of a. And now, hey, look at this. That is exactly epsilon. And so it seems that we get the desired result. Now, as I said, this is an incorrect proof. So what incorrect thing might have happened? So one incorrect thing that you might point out that looks suspect is you should always be a little bit worried about division by 0. And this thing in that parenthesis, that could conceivably be 0, right? So that's bad, but that's not that bad, right? That would be easy to fix. You could do a case-by-case analysis. We would wind up with one of the cases being when both of those things are 0, and that's an easy case to deal with. Something that's worse, though, is, check this out. This quantity depends on little n. But let's see why that's bad. So let's just recall the definition of limit. So the definition of limit is that for every epsilon bigger than 0, there exists some big N such that for all little n bigger than big N, absolute value of a sub n minus a is less than epsilon. So in particular, look at this. This choice of epsilon is something that can't depend on n. It can't depend on anything. You have to consider any epsilon. In particular, this epsilon that you get is totally independent of all of these parameters. In particular, it's independent of little n. We'll see what happens up here. There's a little n in there. So that's bad. And in particular, one really good demonstration that this is an absolutely terrible thing to do, terrible idea to try to do. Well, what if I write this? So there's a line up there where this is the line that is upsetting to me, so I guess I should write it. We can arrange that the absolute value of a sub n minus a is less than epsilon divided by absolute b sub n plus absolute a, and absolute value of b sub n minus b is less than the same. I think these parentheses do matter, so I'll do my best to include them by taking n big enough. So as I pointed out, the thing that blank can't depend on n. It has to be a constant. Otherwise, here's something really wacky you could do. Just by putting something different in that blank. By taking n big enough, we get that absolute value of a sub n minus a is less than absolute value of a sub n minus a. And that's obviously a straight up contradiction. So if this quantity you put up here is allowed to depend on n, then absolutely nothing ever can converge. And that would be a bad state of affairs. So let's try to fix that. And this video is already 8 minutes. Otherwise, okay. Other than that, I say the proof is okay. There's this issue with division by 0, but when we fix this, it'll actually fix that issue too. So the whole problem is that there's this dependence on n in terms of the b sub n. So if we can take the b sub n bit, even the absolute value of b sub n, and replace it by something that's independent of b, we would be happy. Well, in particular, as I said, b sub n is close to b. So the idea is that just because b sub n is close to b, it can't be gigantic. Like I almost literally said that earlier, I think. So let's do this. So surely if b sub n is close to b, well, surely then the absolute value of b sub n is pretty close to being the absolute value of b. In particular, the absolute value of b sub n has to be less than the absolute value of b plus 1. And I mean, that's not, I'm not saying that's true for all n, I'm saying that's true for n big enough. So let's kind of see how to do this. Let's is a contraction which is both informal, and so you should not use in a formal proof. We're not in a formal proof right now. And it's a contraction, so it needs an apostrophe. By taking little n to be big enough, we can arrange that the absolute value of b sub n minus b is less than 1. That's certainly true. Now, let's start with the absolute value of b sub n and add and subtract b in order to find explicit bounds on absolute value of b sub n. Well, so b sub n apparently then is the same as the absolute value of b sub n minus b plus b. And the whole reason to do that is, hey look, there's something that I have control over. I've bounded that. So by the triangle inequality, that's less than or equal to absolute value of b sub n minus b plus absolute b. Hey, that's strictly less than 1 plus absolute b. All right, great. So by taking little n to be big enough, we can get this. So let's kind of take this informal proof and say how to fix it before we write the formal proof. By taking little n big enough, we can then get that a sub n minus a is less than something, anything we want, not this, but something else. And the same thing with b sub n minus b. But let's use kind of the same logic. A sub n minus b sub n minus a times b, that's the same thing as a sub n times b sub n minus a times b sub n plus a times b sub n is equal to absolute value of a sub n minus a times b sub n plus absolute value of b sub n minus b times absolute times a. I haven't used the triangle inequality yet. But now I can use the triangle inequality to get that this is less than or equal to the absolute value of a sub n minus a times absolute b sub n plus absolute b sub n minus b times absolute value of a. And so now you just kind of stare at this for a second. This I can make as small as I want. So that's going to be one of the things that we just have in a blank. Times b sub n, we have some control over that. That's less than absolute value of b plus 1 plus, hey, b sub n minus b, that's one of the things that we have bounded above by a thing in a blank, times the absolute value of a. Maybe color coding. This corresponds to the green, this corresponds to red, that corresponds to red. Oh, but let's just write down what that is. So there's whatever we have in the blank. I should have given myself more space here. Lesson long. Too late for the video, though. I'm not going to re-record it. Times the absolute value, well, I'll like factor out. Absolute value of a plus absolute b plus 1. Aha! What can I put there so that this works out to be epsilon? Well, I guess epsilon divided by that. So let's assume that by taking little n big enough, we can get absolute value of a sub n minus a to be less than epsilon over absolute a plus absolute b plus 1. B sub n minus b less than epsilon divided by absolute a plus absolute b plus 1. So now we'll just paste that everywhere. And there's a shortcoming of doing this like freehand fill in the blanky things. I'm going to wind up screwing up my spacing. All of those should have been epsilon divided by absolute a plus absolute b plus 1. And we kind of see how the proof is supposed to go now. So it looks like, because I'm at 15 minutes, so I'm going to stop the record and on the next side there will be the formal proof. How will the proof go? So I can start by considering any epsilon bigger than 0 by picking big N appropriately and taking little n bigger than big N. I will arrange that b sub n is less than the absolute value of b plus 1, that a sub n minus a is less than this blue quantity, that b sub n minus b is less than that same blue quantity, and then I'll do this. And that's how the proof will go. So maybe I'll even pause here. There's like a fill in the blank approach on the next page. What I encourage you to do, I'm going to upload a thought video all at once. And in that thought video, I'll go through this sheet, but what I'll encourage you to do right now is just fill in them blanks. And then either get stuck and then watch the video, or fill in the blanks and then watch the video again. All right, I'm stopping now.